we're going to look at here is how to simplify a fraction that involves algebra in the example that I've got on the screen, or perhaps a fraction involving surds, something complicated. Now, if we were asked to simplify the fraction that you can see here, a lot of people, I'm afraid to say, would just say, oh, there's an x squared, there's a 16, let's cancel different things. Let's perhaps do something like that. We get something like 8x over -1. The answer must be -8x. People will tend to say something like that. And it could not be more wrong. It's awful. It's as bad as taking the fraction 47 over 48, noticing that there's a 4 in both of the numbers and saying that it must be 7/8. It's just as bad as that. It's absolutely terrible. Okay? You cannot go that way. So let's go back to the original example and consider what you must do. X squared plus 8x plus 16 all over x squared minus 16. And perhaps before we do this, it would be worthwhile just considering how you cancel what you might think of as a normal fraction, a numerical fraction. Let's have a look at something as easy as perhaps 4/8. Now you know as well as me that that makes a half. But why? Have you ever really thought about why it makes a half? Well, we can factorize 4. We can factorize 8. We notice that they have a common factor of 4, and so the answer is a half. We factorized the numerator, we factorized the denominator, and then we cancelled. We cancelled when we had a string of multiplications. That is how you cancel or simplify any fraction. It doesn't matter how complicated it is. I'll repeat it. You factorize the numerator, you factorize the denominator, and then you can cancel any common factors. That means the only way to handle this is to factorize the numerator and factorize the denominator. So you need to know how to factorize a quadratic. Different people have different methods, but you should be able to get that for the numerator. This is the difference of two squares. This is x plus 4, x minus 4. And you can see now that we have a common factor in the top, which is also in the bottom, x plus 4. So I can cancel that with that. The final answer is x plus 4 over x minus 4. I cannot go any further. I cannot cancel these x's. I cannot cancel these 4's. Why not? Well, let's take a look. Suppose I had 9 over 1. I could think of that as 5 plus 4 over 5 minus 4. Is it possible to cancel those 5's? Is it possible to cancel those 4's? No. So it's equally not possible to do any cancelling here either. You must have a string of multiplications, just as we did in this numerical example here. A string of multiplications, then you can cancel. If it's not a string of multiplications, you cannot cancel. Now, last comment for this video. It was only possible to simplify when these were factorized. Therefore, if you are provided with a fraction where the numerator in particular is already factorized, this one wasn't, but if it had already been factorized, it would be silly to expand it, because you might need to cancel, you might need to simplify, and in that case you need the numerator to be in brackets already. So why would you take it out of brackets? Leave the numerator factorized, and it might just help you simplify the fraction. I hope that was helpful.